really cold, 4 degrees, that's in Fahrenheit. And this rock outcrop here is what I'm going to talk about. I've actually done a video from this outcrop before, coming up with a basic hypothesis of what's going on here. As you can see, there's white rock and green rock that I'm going to get into, well, gray and greenish rock anyway, I'm going to get into here in a minute. But my original idea wasn't entirely correct. I have subsequently studied this in great detail. This is my lab book. I took samples from here earlier this month and did detailed analysis, detailed description, some basic petrographic analysis, and I think I know what's going on here, and it's rather kind of interesting. Now, I'm going to talk about the setting, the general rock real quick so you can get a picture of it. You basically, just by looking at this, you see two basic rock types, which you can tell just by color. You can differentiate the two here. That doesn't usually happen, but you can. You see the darker host rock, this greenish gray, and this is the Michigamme Slate Michigamme Formation. Now, this formed in a four-arc basin. The Michigamme was deposited towards the end of the Paleoproterozoic, about 1.77-ish to 1.85 billion years ago with a B. As you had a continent from the south, the Wisconsin terrains, moving up, meeting with the existing Archean and Paleoproterozoic continent of the Upper Peninsula in Ontario to the north, starting to form North America during what was called the Pinokian orogeny, and an orogeny is basically a mountain building event. Now, this closure, this meeting, the formation, this building of North America, as these two continents came together and one subducted under the other, in between you would get sediments. These were those sediments. And as they were deposited and the continents got closer together, what happened is they became deformed. You get them deposited and they would bend and fold, and these right here are turned almost direct or almost vertical. The bedding planes are right about this way. That way strike, that way's dip. So this continent came together, these two continents collided and formed, and well, what's this white stuff? Now this is the interesting part, because originally I just assumed by looking at this that this was a hydrothermal deposit that came later. Well, we know during the Mesoproterozoic, about 1.6 billion to 1 billion with a B years ago, something occurred. Now, North America had already been essentially assembled at that time, about 1.6 to 1.4 billion years ago. But this intrusion, we had a massive event called the Wolf River event occur in Wisconsin, south of here, hundreds of miles. Well, close to a couple hundred. I'll correct it if I'm wrong. So that could have served as a source for this. Well, it's not hydrothermal. Why is it not hydrothermal? Well, it's not hydrothermal because it's magmatic. The white quartz in here is a quartzolite. It is crystallized directly from magma. How do I know that? Well, I analyzed it and took samples, but you look at it here, and for anyone who knows about Bowens reaction series, you know, as a rock, a magma body, provided it has all the chemicals needed as it begins to crystallize and form minerals, because minerals are solids. Magma is not a mineral, it's a chemical concoction. It's a liquid. Certain minerals will form from the magma in a specific order. Now, it's not perfect, but this work was done at the beginning of the 20th century when we actually started to melt rocks and figure out what was what. Well, you have two basic series, a continuous and discontinuous, which for the purpose of this don't matter, okay? But at the bottom, you see they come together in a series called a residual series. Now, I'm not going to get into the detail continuous and discontinuous, because the magma that this represents, that came up through the Michigamme here, was not very hot but it was hot for a while. You look closely at the white quartz here, and you don't see any like distinct hard crystals. There is weak crystal development, but they're large. I mean, like on the order of my pinky size, okay? But this whole thing right here, you see these veins coming up. You'll see them over here. I'll get into those stringers over there, but from a bigger picture, it's only right here. Now, you can't see because of the snow, but these go up. But this here represents sort of like a mini magma chamber. Well, how do I know this white quartz crystallized out of magma and isn't hydrothermal? Because you look down here and you have light-colored muscovite. Now, on Bowens reaction series, the residuals, you get muscovite crystallizing out, and then finally you get quartz. Well, so this magma, even if this magma had other things in it, like a lot of calcium or a lot of mafics, like iron minerals, magnesium minerals, those crystallized underground a long time ago and we can't see it. But the remaining very silica-rich magma came up and started to pool in this magma chamber because we just get the mica down here at the bottom. We don't get it. So what happened is this would have been injected, filled this chamber, this void, whatever created it, could have just been a cavern from tectonic displacement. And the muscovite settled first, culminated out to the bottom, and we were left with the white quartz to crystallize last. And in both Bowens reaction series, the quartz would have been the very last thing. We do see a bit of the country rock of the Michigami, this, in the quartz, indicating that it was reincorporated into this relatively cool magma anyway. Okay, so that's my line of evidence for why this is a quartzolite, cooled directly from a magma and not hydrothermal. This would have been warm anyway. I mean, quartz crystallizes at this depth and pressure, probably 600 degrees centigrade. So it's not really hot, but it's hot enough to keep it a liquid for a while. And you look here, more lines of evidence that this is a magma injection and not hydrothermal, is you see these breaks of quartz, and there's more of them, but they're covered with snow, that come out this way. These would have been weak cracks that magma could have gone into, and you don't see the muscovite in here, but you do see a reabsorption of the country rock a little. So you can see the crystals are a little smaller too. So that probably happened during the Wolf River event 1.45 billion years ago. After that, well, it was deep underground. We had some time pass, but essentially this is what I think happened. The diagram, see it? There's your magma chamber. The green would be the muscovite settling out. The blue's the quartz or magma, and essentially that's what I think what occurred. So I just like it's like this because quartzolites are supposed to be rare, but since me and Sarah have been up here for the past couple years looking around, I'm finding more and more of these magnetic quartz bodies. And they could contain hosts of minerals that no one's really looked for before. So there's some practical application to exploring these. Horse Race Rapids has a very large igneous quartz body. But anyway, if you have any comments or questions, leave them below. That's it, and I hope you learned something.